Welcome back, pre-algebra. We are in lesson 45 and we are going to talk about volume. And we have already discussed area. Area is what we say is the word we use to represent the size of a surface, right? This is a surface here. We have a rectangle here and it's 4 inches by 5 inches. So the size of this surface is the length times the width, or the height times the width, whichever you want to call it. 4 times 5, that would be 20 inches square. And we can actually visualize that by cutting this into 4 rows this way, 4 1-inch sections here, and then 5 1-inch sections here. All right, this is not perfect, but it's an illustration. So then you could go 5, 10, 15, 20 cubes or 20 squares here because squares are flats. So this is area. This is what we understand about area, that we can do the multiplication and find the number of single units of that unit of measure within this surface. Volume is very similar, except that now we're adding a third dimension, and that dimension is going to be depth. Sometimes it's depth. Sometimes that dimension is height. It just depends. So here is a cube, and I'm going to illustrate. We have a height here. So we have a height dimension. We also have a base or a width here, but then we also have a depth. Technically, this would be called your length, right? Width times length. So the area of the base would be the same as the area of this right here, this shape that we're given. So what we do to find volume is we find the area of the base here, and then we multiply it times the height, and that gives us the volume, right? So the area of this shape on the base, this is 5, and this is, actually, let's say this is 4. That'll be a lot easier. 4, and this is 2. And because this looks like a square, I'm going to say this is 4 tall. And this is all in meters. So if I have 4 meters this way and 2 meters this way, then the bottom of this box here is going to be 8 meters square. We can get that just by looking at these two. So the base of it, the surface of the base, is going to be 8 meters squared. But the volume is what's inside the box. How much can the box hold? And we get that by multiplying the area of the base times the height. So what it basically does is it says, okay, we've got this section here of 1 meter units all the way across the bottom. So that's 8. We have 2 this way, and we have 4 this way, right? So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 units that are in cubes across the bottom. But then we have 4 of these sections stacked up. 1, 2, 3, 4. And if there are 8 of these in each section, then 4, we need to multiply that by how many sections we have on top of each other, right? So that would be, let me erase this a little bit. If we know we have 4 by 2 here in this section, right? Then in each section after that, we would have 8 here, we would have 8 here, we would have 8 here, and we would have 8 here. 4 of these 8 sections, that's the height, 4 meters. They're in meter lengths or meter heights here. So 4 of those would be 32, because 8 plus 8 is 16, plus 8 is 24, plus 8 is 32. 8 times 4 is 32 meters, but now we have to indicate that it's 3 dimensions. So we have to put a cube on that. And you can look at it mathematically as meters twice, meters a third time. So we add the exponents here to get 3. So 32 meters cubed represents volume. And if you don't have the exponent of 3 on your unit of measure, it is not volume. And I don't know that it's volume. Without this, it's just some number hanging out in space. I have to have the unit of measure with the appropriate exponent to know that this is volume. And that appropriate exponent is 3, because that tells me I have the 2 dimensions of area and a third dimension of height. And that is why we say that physical objects like a box or a ball or a chair or a table or house is 3-dimensional, because it's not flat like a piece of paper. And technically, a piece of paper is 3-dimensional also. It's just that that third dimension is so small, we can't really see it with our eyes. It has to be measured digitally or with a caliper. But because it's so tiny, we use it as an illustration. But it does have a height dimension. Think about when you have a stack of paper, right? All of those dimensions add up. There's like a stack of 500 sheets of paper is usually about 3 inches tall, right? So that tells me that there is a height to paper. It's just so small, it takes a lot of them for you to see it. That's the same with everything in our physical world, regardless of whether we can tell it actually has a height or not. It does. Everything in our world, in our physical world, has 3 dimensions: a length, a width, and a height. Or based on your perspective, it could be a height, a width, and a depth based on how you're looking at it. But this is the formula that you need to write down in your notebook for volume. The area of the base times the height. That is how we find it. So let me clear the page and let's look at a shape. All right, in 45.1, we are given a cube. It's a rectangular cube. And we are given the area of the base illustrated here. Now you can see that duplicated over here. The area of the base is 2 centimeters by 6 centimeters. So we find for volume, we're asked to find the volume. For volume, we find the area of the base times the height. All right, well, the area of the base, this is where we start using our parentheses in our calculations. So the area of the base, as illustrated here, this is the base, which is the same thing here on the bottom. We have 6 centimeters times 2 centimeters. And then that is going to be times the height, and the height is 4 centimeters. So we're going to put 4 centimeters in for the height. Okay, 6 times 2 is 12. So that's going to be 12 centimeters square times 4 centimeters for the height. 12 times 4 is equal to 48. And centimeters squared times centimeters once, 2 plus 1 is going to be 3. So 48 centimeters cubed is the answer to this volume problem. All right, let's do another one. All right, so here we have 45.2, and you kind of see this is an irregular shape. And that's why it's so important to think of this in terms of the area of the base times the height, because sometimes we have to do complicated calculations in order to find the area of the base. With a box like a square or a cube, it's easy because we have 3 dimensions and we can multiply them straight across. But when we have a complicated base shape, we can't really do that. Take, for instance, this base shape. We have a slanted side here and a flat side. It's a pentagon. 1, 2, 3. Well, no, it's not a pentagon. It's a 4-sided shape, but it's weird. This shape, this side is shorter than this shape, and it creates a slant. So we are going to have to break that down into a rectangle and a triangle in order to find the area of the base. And that would be illustrated just like that, right? Here's the area of the base here and here as well. It's given to us so that we can see it better in a flat area illustration. So we're going to do this here. And we have area 1 and area 2. So we have 4 by 6 for area 1. Area 1, and this is in the dimension of feet. So that's going to be 6 feet times 4 feet, which gives us 24 feet squared. Now we find area 2. We know that's a triangle, so we have to find the dimension for the height, which we see. We do the look across. The look across tells us that this is going to be 6. And our base, if we do the look across here, this dimension is 4. 10 minus 4 means that this is going to be 6. We don't need that 10 anymore. So 6 by 6, but it's a triangle, so 6 foot times 6 foot, but it's a triangle, so we divide it by 2. 36 divided by 2 is going to equal 18 feet squared. So the area of the base is these 2 dimensions combined. So that's going to be 12 carry 1. That's going to be 42 feet squared for the area of the base. So now we can take this area of the base and multiply it times the height, which is 6 feet. It's illustrated on this dimension here. 6 feet. And we find that 42 times 6 is going to give us 252. And now this becomes feet cubed, because that is going to be the volume is equal to the area of the base times the height, in that is going to be a cubic dimension or a cubic unit of measure. So the answer is 252 feet cubed. So find all of the area of the base and then multiply it times the height once you've added it together. That is why we say, instead of saying what you probably have heard in the past is length times width times height, the 3 dimensions multiplied together. And that's true. That's true. But you can't always do that for every dimension you see, because in this instance, we had a triangle. And with a triangle, we don't just do length times width. We have to do length times width divided by 2. So our formula for a volume is always going to be the area of the base times the height. Okay, that is volume. All right, and that is all that we have, I do believe. Yes, that's all we have for lesson 45. I will see you in lesson 46.